Good afternoon, everyone who's online and have called in. Each year for 6 years, we have been coordinating the natural resource fairs on the Navajo Nation. Due to the coronavirus, this year we have resorted to virtual communications. Our webinar today is 4 of 6 webinars for the Natural Resource Fair. Our presenter today is Benita Litson. She is the director of the Land Grants Office at Diné College in Sahealing, Arizona. The Land Grants Office is a partner since the Native American Producer Success Project began in 2013. We've had numerous events working together with the Land Grants Office staff. They are a dedicated crew improving farming and ranching while working with many producers here on Navajo. Our session today is one of many trainings they provide. If you notice on the flyer sent, tomorrow is another webinar, Rangeland Health. Be informed on September 29th and 30th at the same time, we will be covering 2 more topics, cover crop and noxious and invasive species, also by the Land Grants Office. Before I turn the presentation over to Benita, I would like to share information about our program. The Arizona Native American Producer Success Project 7 is a collaborative effort between Developing Innovations in Navajo Education, a nonprofit organization, New Mexico Cooperative Extension Service, and the Diné College Land Grant Office. The project is funded by USDA Office of Partnership and Public Engagement, Outreach and Assistance for Socially Disadvantaged and Veteran Farmers and Ranchers program. The goal of the Arizona NAP 7 project is to increase the profitability and long-term sustainability of Navajo farmers and ranchers. To achieve this goal, activities in 4 key areas are being undertaken to improve Navajo farm and ranch operations, to increase Navajo farmer rancher knowledge of and access to available programs and technical assistance provided by the United States Department of Agriculture, the Bureau of Indian Affairs, the Navajo Nation, and the New Mexico Cooperative Extension Service, including the Diné College Land Grants Office and others, to facilitate Navajo farmer rancher use of USDA's Natural Resource Conservation Service, Farm Service Agency, and Risk Management Agency programs, to strengthen the organizational capacity of the Navajo Farmer and Rancher Congress to address the current and future needs of Navajo farmers and ranchers. Our contact information for the Native American Producer Success Project 7, I am Sadie Lister, the field coordinator. You may reach me at 928-637-5633. Sharon Sandman is the assistant field coordinator. Her cell number is 505-427-4262. We also have colleagues with the New Mexico Native American Producer Success Project 6, and they are Jana Johnson and Jesse Jim. And of course, our fearless leader, Michael Patrick, with New Mexico State Cooperative Extension Service.
Okay, well, good afternoon. My name is Benita Litson. I am the director of the Land Grant Office, as Sadie has indicated. Today, I am going to be presenting about soil health. A little bit about our office, though. As Sadie has mentioned, we have been partnering with NAPS for the past 6-7 years in regards to trying to offer programs to farmers and ranchers throughout the Navajo Nation on improving their current operation, whether it's a farmland or a ranch, connecting them to resources and being able to assist them in creating a productive agricultural on their agricultural endeavors. So with that, it's been really good to collaborate on many of our topics as we present throughout the Navajo Nation. As we bring in many expertise in the different areas, we too also learn and gain from those experiences, and what we learn we're able to share with you. And that way we're not relying on bringing in outside resources so much. So with that, we've been given the opportunity to be able to share our knowledge with the farmers and ranchers throughout Navajo. My clans are Sanjikan and Shle, Tachini Bashashin, Kiani Dashache, Dototani Dashanella. I am originally from the Taili Wheatfields area, so I'm privileged to work in my own community of Taili. And, you know, I love my work in regards to establishing programs, you know, with workshops, seminars, hands-on activities for our farmers and ranchers, so they improve on what they are doing at home and just trying to bring some new techniques that they can incorporate into what they're currently doing. With that, we will go into the presentation on soil health. So what is soil? Soil is probably one of the most important element that we need today. You know, it's our Mother Earth, of course, and we definitely need to take care of it as it takes care of us. But its main purpose is to help with medium for, you know, the plant growth. It serves as anchoring roots for plants. It also supplies water to the plants. It provides air for plant roots. Also furnishes the minerals that plant need. So in reality, your soil should have 20 to 30% air in the soil, also 20 to 30% water in the soil, and our minerals should include 45%. Our organic matter is 5%. As we move forward, we'll kind of understand what these components do within our soils, but basically this is what we would want to see in a healthy soil. So a lot of times, especially in our rangelands, like today, we have not received rain or adequate rain or moisture through the summer. So our soils are really, really dry. And so you start to see a lot of plants that are either dying or going into dormant early. And so there's a lot of things that are happening within our soils that also really relates to the health of, you know, what's above the soil. So the plant growth, the air, all of these components combined. Soil consists of particles, which are either organic matter or minerals, of course, water and air. So we have our mineral particles, classification and sizes. So primarily we indicate that soils are either clay, sand, or silt. And below you'll see the picture of a loam sandy soil and clay, and that's just to kind of give you an idea of what they would look like. But in reality, we normally would see gravel, sand, silt, and clay as our main particles. Gravel being the largest, of course. We can feel that in our hand. It's you know, rock structure. We can pick them up. They're pretty big. They're more than 2 millimeters in size. Sand, they're a lot gritty. So if you pick up sand, you can really feel the granules in your hands. So they're a lot bigger, 0.05 to 2 millimeters. And then your silt is 0.002 to 0.05 millimeters. So it's very, very fine. And it's floury. So if you make a lot of dough, that's kind of how silt would feel with the flour. Then you have clay, which is a lot of the smaller particles. They're less than 0.002 millimeters. So some examples of understanding what your soil classifications are. I don't have it on the screen, but there's a jar test that you could do. You would be able to get a clear glass of jar, put your soil medium in there at half, and then fill it up with water, shake it vigorously, and let it set for a day. And then, you know, when it settles, what will end up happening is the bottom layer of your soil would end up becoming the heaviest layer, which would be your sand. And then your middle layer would be your silt, and the top layer, your clay. and then your organic matter kind of floats around on the top of the water. So that's kind of how you would analyze your soils if you wanted to do your own little testing. Then we'll move into structure. So soil has various structures. So you have granular, as mentioned, like your sandy soil. Then you have blocky, prismatic, columnar, and platy, and single grain. So below there's sort of like the actual images of what that would look like. Platy would be like the crusting of clay soil at the top. If you were, when you guys were children, you start to see that crusting of the soil. You pick it up, it kind of looks like these little mud cakes. That would be like the platy structure. So there's various sizes to various structures to your soil. And so once you kind of get the hang of playing with your soil a lot more and kind of understanding how they form, you get to understand, I guess, the different categories that it would fit in. And this is important as you start thinking about irrigating your crop or how well water infiltrates through your soil. Moving forward, a few more pictures. So the one on the one here, if you can see the little cursor here, the arrow. So you have your single grain soil, which is kind of your sandy soils. You see how water hits it and is able to infiltrate really, really fast. So a lot of times your sandy soils, water will travel through quickly. And then you have your blocky soils, which kind of creates sort of like a maze system for your soil. And so it infiltrates a lot, at a slower rate, not too slow though, still has, pretty quick. Then you have your platy, which kind of forms at a diagonal, in a diagonal way, and it's difficult for water to kind of travel through that because it creates those little pockets. So that's what I meant by how it's important to kind of understand what your soil structure is like, so that you know how the water flows through, even your plant root systems, different things like that. Here, there's just a lot more pictures in regards to what the structures would look like. So some of us, we see columnar, you see the cracking in the soil, and you see a lot of linear soil structure, like the prismatic here. Then you have more platy, your granular. So sometimes in our fields, we might have several different types of soil structures in our cropland or your rangeland. That's why it's really important to kind of understand and identify the different types of soils that you have in either your field or range. So you start to understand how water travels through, what's the water holding capacity, and how plant life is able to sustain itself. So then we go to soil pore space. As mentioned, if the bigger the soil size, it's sort of like putting marbles in a jar. So the bigger the soil size, you're going to have a lot more air space in between the soil particles. And so you see on this side, you see a lot more pore space. So you start to see water and air kind of fill that particular soil particle. As you get to your clay and your silty soil, they start, because they're so small, they start to kind of choke out the opportunity for water and air to move through the soil. So it's really good to start thinking about ways that you can start amending your soil, just adding different materials that might be able to help allow that soil to breathe or allow water to transfer through. So there's a lot of things going on in the soil. There's a lot of things that we don't see. So there's a lot of microscopic things like mycorrhiza, the different fungi that's happening, the root system, how water is absorbed, the different different, elements that are in there, like the worms, and they help to create space in your soil so that it becomes porous, and it also provides nutrients to the soil, by breaking down a lot of that dead material and adding that to your particular soil. So those are things that you want to really think about moving forward. So then you go into your soil structure. I mentioned earlier a little bit about what we would consider like the jar test, understanding what your soil texture is. So there's a lot. If you see on the side, we have from sand all the way to loam, and there's different categories that they would fit in. So in your sand or your jar test, depending on the percentage of sand, silt, clay that you see in there, you'll use this particular chart to be able to understand what kind of soil you do have in your particular field or rangeland. I know it's a lot, but it's something to kind of help you become familiar with your soil. We do through NAPS and Dene College, we are, if COVID was not here and we could do a lot of these hands-on workshops, so you get to understand how your soil feels and be able to see how we utilize this chart. So thinking about our soils, if we were going to dig into the soil up to about 3 to 4 feet, this is kind of what the soil profile would look like. You see your O horizon, which is mostly your organic matter, which is a lot of your dead materials. And you'll see that it's a little bit darker just because there's a lot of decomposition that's happening within the upper layer of the soils. And then you have your A. There's still a lot of activity in regards to root structures within the soil. It's a lot darker, richer in regards to that, and that's usually found from 2 to 10 inches within your soil. Your B is then your subsurface horizon, which sometimes includes iron, aluminum, and then moving to C, which is your weathered bedrock. Then there's an R, which is hard bedrock. Actually, in where I live, I feel like we have organic matter, we miss the A, we go straight to the B, and it's not a whole lot of B, and then we go to bedrock. And so everywhere, wherever we live, we're definitely going to see something different. And so that's kind of important to kind of understand too. Like I was saying, I know we're working with a farmer in Rock Point who is struggling, and this is not lower Rock Point, this is above as you're going toward Rough Rock. What we're seeing, or what they're identifying, is that their plants are not growing as high as they should. And also, and what we're finding now is when we started tilling out there, not too far below the top surface, there is bedrock. And so there's no other place that root system can go because we start hitting rock. So we're working with them on trying to add soil to the top layer, make it a little bit deeper, adding in a little bit more organic matter, horse manure, different things like that, and adding that to the soil so that we increase the amount of space that root structure can grow. And so we're playing around with that, but definitely, like I said, every soil is different as we move across the nation. Our soil plant interaction, this is really what happens within our soil. So like I had mentioned earlier, there's water, there's air, there's minerals, all in our soils. We also have different biotic bacteria, beneficial bacteria, lots of different things that are going on within our soils. And that's adding nutrients to the soil to allow for plants to consume and grow. So you see on the picture on the right, you see a lot of the nutrients or the minerals that's needed for plants to grow. And so that's kind of how it interacts. So within this picture, you see the left-hand side, you have some good plant growth happening, and you have a lot of diversity in regards to the different types of mineral that's available in the soil. And you see that on the top, with the leaves and the structure of the plant. It's so much healthier. If you go to the right-hand side of that particular picture, you're not seeing, it's showing that there's a depletion in some of the minerals in the soil. And so that activity is also doing the same up above in the particular plant. And you start to see the plant start to struggle. You start to see discoloration in the plants, really trying to indicate that it needs some sort of mineral to continue its growth. There's things, as we move forward, I'll be talking a little bit more about what macro minerals are, but here's another picture of what happens above the soil and within the soil. I have pictures of the phosphorus cycle and nitrogen cycle, which are a huge part of what plants need to grow. And so this is how those particular minerals are put back into the soil. And so I just wanted to share a little bit about this. So what happens above ground in our air, in our atmosphere, definitely has an effect with what goes back into our soil and how it's decomposed back into nutrients for plant growth. So soil, I talked about macronutrients. The N, P, and K, nitrogen, phosphorus, and potassium, are known as the macronutrients, meaning it's always going to be changing and it's quickly utilized by the plant. And so when you see a deficiency of a particular nutrient, it's most likely going to be N, P, or K, just because that plant is consuming so much. So you're going to have to add in, an additional nitrogen, phosphorus, or potassium into your soils to help that plant, either fruit more and grow healthier. The nitrogen helps for amino acids to build proteins in your plant. Phosphorus used to form nucleic acids to develop root systems, the early growth and maturity of seed production. Where potassium is used in the root formation and promotes disease resistance. It also increases the size and quality of the fruit. So as mentioned, these particular nutrients are the main things that is needed for plant growth, and you're going to see a deficiency within your soil because your plant consumes so much of that. Your secondary nutrients are your sulfur, calcium, and magnesium. Sulfur has to be present to form the proteins. Calcium is used in the root system and leaf development. Magnesium is the central atom of the chlorophyll molecule that helps metabolize phosphate in plant respiration. So these are the next, which we call secondary nutrients. They're still used as much as N, P, and K, but it's not so much depleted, as quickly. Your micro or other nutrients that's needed. You have copper, iron, manganese, molybdenum, zinc, boron, and chlorine. So these all help with the different plant growth phases, root structure, photosynthesis, chlorophyll production, carbohydrate. So these are also all needed, but they're not needed in larger amounts. So you're not going to really see a lot of micronutrient deficiencies. However, in our area in Saley, we actually have seen zinc as a deficiency. We're having problem with squash growth, and that was something that was indicated to us after soil testing. So once we added the zinc, our plants definitely started to take off. So it's pretty good in regards to taking your soil samples before you start planting, so you kind of get an understanding of what your deficiencies are and are able to find the particular fertilizers or additives or different, like compost that you might want to be able to create and add to your soil. Another important part of your soil is the pH levels. So pH of 7 is considered a neutral area, and most plants like to be within that area. Your pH 1 to 6 is considered acidic, 8 to 14 is basic. And so the power of 10, the power of hydrogen, it says each value is 10 times above or below. And that's more we don't really need to know that part just yet. But in regards to there's, depending on the plants that you are growing, you want to be able to try to stay within your pH levels of 7. And sometimes if you live in the forest area, your soil might be a little bit more acidic due to, like the pine needles dropping, and mostly, those type of activities. So it's pretty good to be able to test your pH levels. So here I just indicated a photo of the different nutrient deficiencies with the plant. So you have calcium, you see the dark greening of the vines, and then you have nitrogen. You start seeing yellowing of your leaves with the darker veins. You have carbon dioxide deficiencies, which has a lot of, showing like the little dead pieces dying on the leaf. And then your phosphorus, you have darker green leaves. Magnesium, you have yellowing on the outside of your leaf. Manganese is the ends, kind of like around your, the main leaf, you'll start seeing yellowing, and then around the vein area, it's still dark green. Your potassium, again, is the outside yellowing, but the tips start to get purple. And then your iron deficiency, just a lot more lighter color. So you start to kind of recognize the different deficiencies in your plants. So next we'll move to water infiltration. It's definitely an indicator of the soil's ability to allow water through the soil profile. So like I mentioned earlier, if you have coarser soils such as your sand particles, your water is going to definitely run through quicker. And then your finer soil is kind of going to hold that particular water in and absorb throughout the soil and then start trickling through the soil. We're working with another farmer in Shiprock, Fruitland area, and right along the river, they have really, really sandy soil. So when you're irrigating, we don't even see water flow more than 15 feet because it's infiltrating so fast into the sandy soil. So you're either having to move your gated pipe, every 15 feet to make that happen, or make sure there's sort of like a downhill so that there's water. Your water is going to move and flow downhill at a certain rate before it starts to infiltrate too fast. So your clayier soils, they tend to take up a lot more water and hold more water. And sometimes, if you have some clay within your soil, that's pretty good. But if you do have a lot of clay within your soils, you start to see like a shrink swell effect, where once it hits water, it swells up and it kind of chokes out that air system, and it's hard for water to infiltrate through. And you might start seeing some ponding on top of the soil, just because it's not allowing the water to infiltrate in through the soil. So it takes some time. My particular field does that. I have clay soils, and I have that particular problem of a ponding effect in one area of my field. So here, infiltration just means a downward entry of water, and then the infiltration rate is the velocity at which water enters the soil or is moving through the soil. Usually it's expressed in inches per hour. So if you dug like a little trench, you would be able to see how much water moves through your soil surface. You can also do this on your own by creating, cutting the bottom side of a cup and putting that on the soil surface, putting water into that particular cup on your soil, and then timing how long it takes to get through infiltrate into your soil. And then you'll kind of get an understanding of the types of soil that you might have on your little field or your rangeland. Poor infiltration is just, when the water is supplied at the rate that it exceeds the infiltration capacity. So as I mentioned, if in the clayier soils, it tends to hold the water in place and not be able to infiltrate. In this particular picture, you start seeing like this little blue line across, and that could be because of possible compaction of continuous tillage. Sometimes when you start tilling your field too much, you start creating this compacting layer at the bottom, and your tractor or your plow is just tilling the top part up, and meanwhile you're compacting this particular layer. And so a lot of folks are going to like a no-till method where you're either just ripping the soil once rather than turning the whole soil around. Let's see, and if this starts to happen, you start to see that ponding effect on top of the soil surface. And then what we see when that happens is your plants can actually drown. They don't have air to breathe. They don't have all the elements that they need to be able to sustain, a plant life cycle. So this here is an example of a pond filling and just ponding up. So what conservation practices lead to poor infiltration? Like I said, if you're excessively tilling your land, you start creating that compaction layer underneath the soil, and you're not seeing infiltration as much, and so you start to see this ponding effect. So it's good to, if you have something like this, it's good to either build up your soil a little more so that you're able to drain this particular water off of your farmland, so that those plants in that area are able to receive adequate water. When you implement burning or harvesting crop residue, that leaves the soils bare. So of course we want to see sort of like a cover crop on our soils, or make sure that there's vegetation on our soils. That definitely improves that. But if you keep the bare ground, and I always use, the Chinle Valley to Vinny Farms as an example. If you drive through there on a windy day, you cannot see, your visibility is low. That's all the topsoil blowing away. And when you start walking, into rangeland, you're hitting ground that's really, really hard, compacted. And so it's really hard for water to infiltrate and plants to grow. So you start seeing a lot of bare ground. Same thing can happen on your farmland. And so tilling the soil just kind of creates disruption of your surface, and of course prevents the organic matter to develop. So it's good to always have some sort of plant growth on your soil. If you can rotate your particular field with different types of plants with different root systems, so that you actually have root action underneath the soil, breaking up the soil, adding nutrients to that soil. And then if you have a cover crop, you want to go ahead and cut that, and then add all those debris back into your soil, so that you start seeing plant break down within your soil and creating organic matter. Sometimes excessive amounts of livestock, of course, can also compact your soil. I know with the holistic management system, They talk about doing an intensive grazing to kind of help graze the grasses quickly and put a lot of animals in that area so that you're able to break down or create little indentations in the soil with the hoof print, allowing seeds to kind of drop in that area. And then when it rains, you start seeing like little deposits of water, little water ponding, so that it's able to infiltrate a lot more. And then allow for it to go into your soil surface and allow for plant growth to happen again. So that's another new technique that some folks are using. The other ways that you can improve your health of the soil is, I think one of the biggest one is just making sure that you have vegetation on the soil growing, so that you have decomposition happening, and that you're being able to manage the crop residue that you might be leaving behind in your soil. And of course, it increases organic matter, and organic matter is just a lot of the dead material that's left on the ground that's allowing decomposition to happen and be placed back into your soils. Cover crop systems, trying to never leave your land bare. So you see the bottom picture. Although it looks bare to us, they try to keep a lot of that debris on the surface, so that it's tilled back into the soil and adding some of those components back into the soil, so that allows for the breakdown, aeration, pore space, those type of things. And so once after this they'll probably put in a cover crop, something that's going to grow above ground, shade the soil, create your root system, and stay there until it's going to either be tilled again or planted again. So one thing that we have noticed within our area of Saley, so we're working on a revitalization program and trying to get farmers back to farming. And what we found is most farmers grow alfalfa, and alfalfa is a high water using plant. And so because we don't have a lot of water available for irrigation, we're trying to find other plants that are just as nutrient healthy and still be able to produce enough hay for their animals, with less amount of irrigation. So we've been playing with that idea, and we're finding that this is where contradiction happens. Is most of the plants that do well in less water are annuals, which means that we're going to have to plant either every year, which also means a disturbance to your soil annually. So that's where the contradiction ends up happening. But there's different ways that we can continue to improve our soil health by either rotating the crops, making sure that we have a cover crop in the system, and we're able to put that particular cover crop back into the soil to improve the health of the soil. So what types of crops help? We have corn, small grains, perennial sod, cover crops, applying animal manure, reduce soil disturbance, reducing the number of trips across the field, crop rotation, and ensuring that you're rotating with nitrogen fixers. You see a lot of people that grow corn usually rotate with a nitrogen fixer, a few years in between, just to be able to add a little bit more nitrogen to the soil, so they're not spending so much money on purchasing as much fertilizer needed for that particular field. So there's several soil testing kits that are available through the various stores across the nation, I guess. Where we typically buy our stuff is usually from Farm Tech, just because we buy them in bulk. It's a really nice NPK kit, which is nitrogen, potassium, and phosphorus kit. And so just to keep in mind, there's a lot of different types of soil testing kits available. You can also purchase these from Walmart, Lowe's, Home Depot, Ace Hardware. So there's a variety of kits that are available. But here's a sample of what you might be able to see. But just a reminder, the main nutrients that you are looking for in deficiencies are your nitrogen, potassium, and phosphorus, just because they are used quite a bit by the plants and they're constantly changing. So that's something that you want to test for the most. There's other testing that's available for your micronutrients. And so you would need extensive information on that. Some of the areas that we do send our soil testing kits, if you're not familiar with doing this on your own, could be to Colorado State University. And they do a really good job in regards to sharing with you the types of fertilizer or the types of crops that they would recommend to grow in that area or in your soil type. Also keep in mind that on your farmland, you might have more than one type of soil. So you want to be able to separate the different types of soil. It's either going to be by texture or color. And you want to separate that and test them separately so that you know the difference between the two types or three types of soil that you might have. So not all areas are going to be the same, so keep that in mind. So with that, we'll move forward to the next slide. So some of the soil erosion examples that I have on the screen are your splash, which is just like the raindrops that might happen, creating a splatter effect, moving the soil from where it might have deposited. Also, there's sheet reel, which is pretty much a larger area which might be flat, and water moving over that larger land base. And then you start to see sort of a channeling effect to a reel or a gully. And so that's moving forward to a more narrower water channel. And then your gully, of course, is when you start to see heavy erosion of your soil. As you see on the bottom screen, you see the gullies can be anywhere from 6 inches deep to this is probably 20-foot width, and the depth is probably around 12 feet. And that's something we commonly see throughout our rangelands also. So next slide also has a few pictures in regards to the different types of soil erosion that could occur. Again, you have your splash, you have your sheet, you have your reeling gully, which develops the little cuts into your soil, and then that moves into your stream and the different channels that you might have. There's several ways that you could really work on mitigating soil erosion. This is an example. You can create the straw bale effect, and this is probably for a sheet reel, just a larger land base that might create soil erosion runoff. And of course, we talked about this earlier, the more vegetation you have on your soil surface, it minimizes the erosion or flow of the water eroding the topsoil. So in this area, this is an example of a sort of a bare ground, so you would see high runoff potential in this area. You also have farmlands. This is probably a slopey area, and as you see, they created these contours within the slope just to kind of mitigate the downhill slope so that it slows down the process of the water running down quicker. In addition, you're able to concentrate your irrigation in certain areas in smaller amounts rather than water just running off and continuously flowing down. So contour farming is definitely something that could be practiced. It does require a lot of earthwork, meaning moving soil or topsoil into other areas so that you kind of create some leveling. not so much in this case, but many people tend to level their fields so that the water could flow evenly across their farmlands. The bottom one on the left is a rangeland. You can also do your own rock brush structures with the things that you might have in the natural environment. So here you see a lot of rock deposit in this little eroded area. And sometimes you know that this eroded area is probably upper and lower. So you could create several different rock brush structures throughout that channel. Literally what that is just putting blocks in place of water rocks or brush, meaning sagebrush, the different types of grease woods, whatever you might have there, trimmings from a tree. You're going to place that into that gully that's forming along with some rocks, and to hold that that soil back or minimize the flow of the water that would be taking the sediments downstream. So you're just minimizing the flow of that water. Therefore, you start seeing some sediments deposit in this area, and you see the gully start to tend to fill back up. So those are some ways that you can mitigate soil erosion or soil loss. I think, but most importantly, I think when you're farming or ranching, you want to make sure that you have vegetation on the ground. You don't want to keep your bare soils too long. So you want to be able to diversify the living species within your soil structure. So I think that's the big take home from this, because long range, that's going to improve the health of your soil and also the health of the vegetation that you might be growing or the crops and forage that's growing on that space. With that, do you guys have any questions?
Thank you, Benita. That was,
I believe,
very good.
yeah.
Yeah, that was really good presentation. Unfortunately, we have a few members on the call today, but as you know, we are also putting this in a video format and also sharing it on Facebook so that we can reach more producers who are able to watch the video. And then we have YouTube now, so we'll be sharing it with them as well. And we are also going to be starting a website, so all these videos that we've done so far are going to be shared in those programs, webinars, our website. So that's what we'll be doing. And I want to thank you, Benita, for getting back and helping me to complete this webinar today. And we'll be in touch. Land Grants Office is our partnering. We have partnership with them, so we work together quite a bit. Despite this COVID-19, we're able to still reach out to them, and they're still there, helping us along and bringing outreach and education to our producers. So thank you, Benita, for helping us today. Appreciate it.
Thank you for inviting me.
Thank you.